Hi, class. I got a question here about problem number 11. It comes from homework 3.3, which is the second homework in unit 3, and it's problem number 11. So I want to show you how this one works. I'm not going to do this exact problem because it's the greater problem, but I'll show you one that's very similar to it. I'm going to go over here to the view an example. Okay, very similar. The only difference between view an example and the problem is the values themselves. Okay, so what we have here is we have 82% of all female heart transplant patients will survive for at least 3 years. 70 female heart transplants are randomly selected. What is the probability that the sample proportion surviving for at least 3 years will be less than 71%? Assume that our distribution is normally distributed. And here in the final part of it, they're telling you the mean of the sample is equal to the mean of the population and that the standard deviation is equal to this. Okay, so what do we do? Well, what we need to do is we need to first start off by finding what is the mean and what is the standard deviation. Now, the problem tells us that the mean of the sample is equal to the mean of the population. So what is the mean? Well, it tells us right here. 82% of female heart transplant patients will survive for at least 3 years. That's the mean. So instead of writing 82%, convert it to a decimal, 0.82. Okay, so now to find the standard deviation, we have to use this formula right here, the square root of P times Q divided by N. Remember what P, Q, and N are. P is the probability of success. So P here, the success is going to be successfully surviving 3 years, which is 82%. The Q is the probability of failure. In other words, that a female heart transplant patient does not survive for 3 years. Well, that's found by doing 1 minus P. And so that's 1 minus 0.82, which means it's what? 0.18. And remember, N is the sample size. What do they tell us is the sample size here? 70. Okay, so fill it into that formula right there. So it's the square root of 0.82 times 0.18 divided by 70. So I'm going to pause the video for just a minute. I'm going to do that calculation. I encourage you to give that a try too. Okay, so I took a few moments and I did this calculation and I got the value of 0.0. I'm going to round it out to 4 decimal spots. 0.459. That's the standard deviation. Okay, so we're trying to find. Okay, so that was our first step. Find P, find Q, find N. Use that information to find the mean and the standard deviation. Why? Because we need to go and find the z-score now. Remember the z-score, x minus the mean divided by the standard deviation. Now, we know the mean. The mean is this right here, 0.82. We know the standard deviation, we just found it. It's 0.0459. What is x? What does x mean? Well, x is the specific thing you're trying to find the probability of. And here, let's go back to the problem. What does it say? It says, what is the probability that it will be less than 71%? So this corresponds, the 71% corresponds to our x. So we don't write 71%, we write it as a decimal, z. So find the z-score. Again, I'm going to break here to do the calculation. So I'm going to pause it here. So if you see a glitch, that's what's going on. Okay, I'm back. So I found that value. I did this calculation. I hope you did too. If you didn't, go ahead and take a break and do the calculation. And here's what I got. I got negative, and here we're going to round to 2 decimal places. Negative 0.40. Kind of worked out. Okay, this is the z-score. This is not the final answer. This is the z-score. You're going to use this to find the final answer. So let's sort of step back from what we have done, and I'm going to clear it all now. We're trying to find the probability that a patient, that the percent number of patients that survive is less than 71%. Now, when you're dealing with the normal distribution, you can't actually find this. What you have to do is you have to convert this. You convert this to a z-score value, this value right here. What's the z-score associated with 71%? Oh, remember, we just found that. We said the z value is equal to negative 2.40. So the reason why we do that is because then the probability becomes, find the probability that you'll get a z that is less than or equal to negative 2.40. That's what we're doing here. And so to find this value, you have to go to the normal distribution chart, look for the value of negative 2.40, and then what is the value in the chart? And so that's what we do next. So here's my normal distribution chart. You have z values along the left-hand side. You have other values along the right-hand side. So how do you use this chart? Well, that's why I hope you're viewing my videos because I showed you that. But let me do a brief review. We have a z value. Remember, our z value here is negative 2.40. And so what we do is we split it. You go in between the first and the second decimal spot. So you get negative 2.4. And then this, because it's in the second decimal spot, it becomes 0.00. This 0 here corresponds to the 0 in the second decimal spot. That's why we get 0.00. So the negative 2.4, you look along the left column right there. The 0.0 here, you look along the top row right here, and you see where the two meet. Boom, 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 boom. Oops. Oh, my pen dragged a little bit. That's the value. That's the answer. What's the probability that that a female heart transplant patient will survive? That 71% will survive. The probability is 0.0082. Convert that to a percentage if you want. 0.82%. So actually a pretty good odds, huh? A 0.82% probability that a female heart transplant patient won't survive to 3 years. That's very good success rate. Okay, that's how this one works. Essentially, basically what this was, let me go back to the problem. Oops. Basically what this was, it was trying to get you to utilize the formula, the formulas here, oops. The two formulas here, the idea that the mean of the samples equal to the mean of the population, and also the formula for the standard deviation. It hasn't really been presented to you in this fashion, but this is what we call, this is actually an application of what we call the central limit theorem. Where if you have a sample that is normally distributed, then you can use that fact to help you find the mean and the standard deviation. I'm sorry, if you have a population that is normally distributed, then you can use the mean and the population, the mean and the standard deviation of the population to help you find the mean and the standard deviation of the sample without having to actually do any calculations regarding the sample itself. So it's kind of you remember back in Unit 1, you took your data, found the mean and the standard deviation using that data. Here, the central limit theorem allows you to do the reverse process. You're given the information about the population and you use that to find the mean and the standard deviation of the sample. Excuse me. And so that's what this is really all about. And so the key to this whole thing is being able to utilize these formulas right here, that the mean of the sample is equal to the mean of the population, and use this formula. Once you have the mean and the standard deviation, then it's just a matter of finding the z-score, and then you use the z-score to go to the normal distribution table to find the associative probability that goes with it. So I hope this helps. Let me know if you have any questions, and I'll be glad to lend a hand.